Okay, so the second theorem about parallelograms is this. If a quadrilateral sorry, that's supposed to be there, is a parallelogram, then its opposite angles are congruent. I'll draw you an example and I'll kind of explain why this works. So we have parallelogram P, Q, R, and S. And since it's a parallelogram, we know that PQ is parallel to RS, and QR is parallel to PS. And say like we have angle Q here. We're told that angle Q, is congruent to the opposite angle, angle S. Why this works is this, okay? Remember parallel lines and angle relationships? I'm just going to extend out these lines a little bit to help us see this. But we know that in parallel lines with the transversal, that the corresponding the corresponding angles, like the one here and the one here, are congruent. And we're also told that the alternate interior angles, given that these are parallel lines and this is the transversal, are also equal. And so therefore Q and S are equal to each other. So angle Q is congruent to angle S. The same thing works with angle P. Angle P is also congruent to angle R. And the reason this works is basically the same reasoning. We know that in two parallel lines and with a transversal, that the corresponding angles are congruent. So because P is equal to that, S will also be equal to that. And since we know that these are parallel lines and this is a transversal, we know that alternate interior angles are also congruent. So therefore, angle P is congruent to angle R. Okay, and we're going to use this in just a little bit. So the next theorem is related to theorem number 2. And again, it has to do with parallel lines and angle relationships. So let's go ahead and call this theorem number 3. Again, if a quadrilateral is a parallelogram, then its consecutive angles, the ones next to each other, or as we've called in angle relationships, same side interior angles, are supplementary, or equal to 180 degrees. Okay, so let's do another example. Same parallelogram, P, Q, R, and S. We're told that PQ is parallel to RS, QR is parallel to PS. And again, let's try to extend the lines to see, angle relationships based on parallel lines and transversals. Now, in any angle relationship, we're told that the same side interior angles are equal to 180 degrees. We're also told that, or we can also deduce this. We know that the corresponding sides are the same. So if this was x, then this would be x, right? And then the relationship between x and let's call this angle y make a straight line, so their relationship would be supplementary or equal to 180. So in a parallelogram, you can go ahead and conclude that the same side interior angles, or x plus y, are supplementary or equal to 180 degrees. And again, because we know the opposite angles are congruent to each other, I'm going to go ahead and label this x and label this y. And this works not only in this direction, but this direction, and this direction, and this direction.